Many classifications have been proposed trying to order the huge variety of coasts into classes with similar characteristics. In fact, so many classifications have been created that it can be hard to make sense of all kinds of types. However, even when there are many classifications of coast, it is possible to enlist a series of common aspects among them. These are 1. Geological factors. Here, the coasts are the result of geological processes. For instance, plate tectonics. Another factor is the nature or source of coastal material. These could be rocks, sand, mud, corals, seashells, etc. 3. Then we have the transgression or regression processes. Here, the gradual relative sea level changes in the long term, and in combination with the amount of sediment supplied to the coast determine whether a coast during a certain period of time has advanced or retreated. In this terminology, transgression and regression are used to describe a horizontal shift of the shoreline. Hence, transgression occurs when the shoreline moves in a landward direction, or the sea level rise and an overall deepening takes place. On the other hand, a regression occurs when the shoreline moves in a seaward direction, so a fall of sea level occurs and overall shallowing takes place. And finally, 4. The processes that construct and erode the coast. For instance, the wind, the waves or tides create erosional landforms or depositional landforms. Taking all this into account, what coastal classification schemes exist? As you know, the coast is an incredibly complex and diverse environment, and can be complicated to establish one clear organization or classification. As mentioned before, coastline evolution occurs over different timescales ranging from storm events to millennia. Because of that, no single classification can be done or can equally serve all who seek to study coastal features for their own special purposes. However, the concern about how they have formed and how human activities affect their evolution has required the formulation of general classifications and also some other specific schemes. The first purpose of classification is to provide groupings with appropriate names that can substitute for a description of the objects that are classified. Only by using specific names or categories can researchers, coastal engineers, and decision-makers communicate effectively. In 1995, Perillo provided a list of factors that are important to define the main processes acting in the geomorphology of the coasts. These are geological factors, fluvial factors, groundwater factors, wave factors, atmospheric factors, and finally the biological factors. Evidently, a combination of these factors will produce different coastal types. This is the starting point to introduce you into a review of some of the most used classifications around the world. We can divide them as follows: the process-related coastal classifications. Examples are the genetic classification based on changes of sea level proposed by D.W. Johnson in 1919, the tectonic control classification proposed by Inman and Nordstrom in 1971, the coastal classification proposed by Francis Shepherd in 1973, and finally, exists a simplified classification of coasts. Also, there are coastal classifications for special purposes. These classifications incorporate a more quantitative approach, since real values of processes like waves, tides, and beach configuration are taken into account. Among the special-purpose coastal classifications we have the classification based on tidal range proposed by Davies in 1964, the classification based on the wave and tide relation proposed by Hayes in 1979. Then we also have the classification of morphodynamic states of beaches proposed by Wright, Short, and Green in 1985. Then there are other classifications like the ones used in Mexico, which are based on the explained before and are adapted and applied to describe our coasts,